In May, a barge loaded with wood chips started making regular trips from Grundartangi, Iceland, to a patch of ocean 190 miles offshore. By September, almost 20,000 tons of wood waste had been dumped into the sea. This effort is part of the ongoing race to reduce atmospheric carbon dioxide levels. Land-based carbon dioxide removal, CDR methods, like direct air capture, are well known. Iceland leads in this field with the Climeworks Orca plant near Reykjavik, which removes 4,000 metric tons of CO2 annually. However, this is far below what experts deem necessary. The Intergovernmental Panel on Climate Change, IPCC, suggests that up to 15 gigatons of CO2 removal per year is needed to limit global warming to 1.5 degrees Celsius. This equates to capturing the annual emissions of 3.3 billion gasoline-powered cars for 80 years. Running Tide, a 7-year-old US-based startup, is experimenting with marine carbon dioxide removal, mCDR, by using wood waste. The ocean naturally absorbs 30% of anthropogenic CO2 emissions, which is 42 times greater than the atmosphere's capacity. Running Tide aims to use this natural system by deploying wood waste, which otherwise releases carbon back into the air when burned or left to rot. Kristin Hrobiartsson, Running Tide's general manager in Iceland, emphasizes the simplicity of their approach. Other mCDR companies are exploring methods like growing CO2-consuming aquatic plants and sinking them into the deep ocean, or using electrodialysis systems to increase seawater's carbon absorption capacity. Despite the growing interest and investment in mCDR, its effectiveness and potential unintended consequences remain uncertain. Nicholas Ward from the Pacific Northwest National Laboratory highlights the need for more research, especially given the limited funding and the urgency of the climate crisis. The U.S. Department of Energy's Advanced Research Projects Agency Energy, ARPA-E, has launched a program called Sensing Exports of Anthropogenic Carbon through Ocean Observation, CO2, to support mCDR technology development. This program recently awarded $36 million to various labs and institutions. Ward's team received over $2 million to study ocean alkalinity enhancement, OAE, a method that increases seawater's CO2 absorption by reducing its acidity. Ebb Carbon, a company co-founded by Matthew Eiserman, is working on an OAE system that could potentially remove over 1 billion tons of CO2 annually. However, Eiserman acknowledges that large-scale ocean acidification reduction is unfeasible. Instead, their goal is to protect local ecosystems like oyster farms from acidification. Other companies are experimenting with enhanced rock weathering, where alkaline rocks are mined, pulverized, and mixed into the ocean to speed up natural carbon absorption processes. Boyd from the University of Tasmania argues that such open systems have the potential to scale to gigatons at low cost. Woods Hole, Oceanographic Institution, is developing sensors to measure carbon concentrations in seawater, which could help companies growing macroalgae for carbon sequestration. However, Ward warns that biomass breakdown in the ocean could produce other greenhouse gases, complicating the carbon sequestration process. Running Tide's experiments with macroalgae have raised concerns about potential ecological impacts. Critics argue that more research is needed to understand the consequences of such interventions. Boyd suggests that electrochemical technologies are safer and more reliable. Despite uncertainties, private carbon markets are thriving, and significant investments are being made in mCDR technologies. However, some scientists caution that relying on CDR may distract from more immediate climate actions like reducing fossil fuel use. Boyd believes that while no perfect CDR technology exists yet, collaboration between businesses and researchers is crucial. He calls for a balanced approach that considers the complexities of the ocean environment.